Good evening from NASA's Kennedy Space Center in Florida. You're looking live at Space Launch Complex 40 at Cape Canaveral Space Force Station, where SpaceX is preparing for their 23rd launch of the year. Liftoff is currently scheduled for 12:30 a.m. Eastern Time. That's 4:30 a.m. UTC. You're looking live at the Falcon 9 rocket that will be carrying the Intelsat 40E communications satellite into orbit tonight. On board Intelsat 40E is also NASA's Tempo instrument. It's an air quality sensor that's fastened to the top of the Intelsat 40E spacecraft in launch configuration. Intelsat 40E and Tempo will be heading into a subsynchronous transfer orbit tonight, eventually going into a geostationary orbit over the coming weeks using onboard propulsion before beginning service later this year, providing broadband connectivity for in-flight Wi-Fi and maritime Wi-Fi services. The Tempo instrument will be beginning observations late this year as well for monitoring air pollution and atmospheric chemistry across North America, across a swath of the continent from Mexico City all the way up to Canada. The Falcon 9 rocket is made up of two stages. It's 229 feet or 70 meters tall. There's a 2-hour launch window available tonight, opening at 12:30 a.m. Eastern Time, 4:30 a.m. UTC. The weather conditions are favorable for launch tonight. The weather forecast coming into the countdown called for a 90% probability of favorable conditions for liftoff. The only concerns were with liftoff winds, ground winds here at the Cape. It is breezy tonight, but those winds are currently observed under the limit for a Falcon 9 launch. And there are mostly clear skies overhead as well, with a full moon looming over the eastern horizon above the launch pad from our vantage point. We're about 4 miles away from the Falcon 9 rocket as SpaceX counts down 1 hour, 12 minutes, 20 seconds until liftoff. My name is Stephen Clark. I'm editor of Spaceflight Now. I'll be providing updates on the Falcon 9 countdown over the next hour and change until liftoff time, as well as the 32-minute mission sequence from liftoff until deployment of the Intelsat 40E spacecraft in orbit. Propellant loading on the Falcon 9 rocket will begin at T-minus 35 minutes. That's when the control of the countdown will be under the management of a ground computer that will control that 35-minute sequence leading up to liftoff. And then at T-minus 60 seconds, control of the countdown will be handed from the ground computer to the Falcon 9's flight computer. So the next major milestone in tonight's countdown will be coming in about 35 minutes or so at the T-minus 35-minute point. That's when we expect to begin propellant loading on the Falcon 9 rocket. Now 1 hour, 8 minutes away from the target launch time for SpaceX's Falcon 9 rocket tonight at Cape Canaveral Space Force Station in Florida. After liftoff, the Falcon 9 will be heading due east over the Atlantic Ocean. The first stage booster will be targeting a landing on a drone ship. This recovery vessel is positioned about 420 miles, roughly 670 kilometers downrange from the Cape in the Atlantic. The booster flying tonight, booster 1076 in SpaceX's inventory, will be going for its 4th flight to space. Later on in our coverage, we'll have clips from some interviews that we've conducted recently with Intelsat, as well as NASA, to talk about the Intelsat 40E spacecraft and the Tempo instrument. The Tempo instrument being a hosted payload on board Intelsat 40E. The spacecraft weighs more than 6 metric tons and is currently enclosed inside the payload fairing. That's the envelope at the very top of the Falcon 9 on Pad 40. We've seen some occasional venting in the last couple of hours from the strongback. These are part of the standard pre-tanking preps before propellant loading begins at T-minus 35 minutes. If you haven't done so yet, please hit the thumbs up or the like button here on our YouTube stream. That helps us attract a larger audience as we get closer to liftoff, now 1 hour, 6 minutes, 20 seconds away. Now 1 hour, 3 minutes from the opening of tonight's launch window, which remains at 12:30 a.m. Eastern Time, 4:30 a.m. UTC. The launch window tonight runs for 119 minutes. It's an hour and 59 minutes. all the way up until 2:29 a.m. Eastern Time, 6:29 UTC. Right now, the countdown is targeting a liftoff at the opening of the window, and the weather conditions look favorable for launch tonight from Pad 40 here at Cape Canaveral, Florida. T-minus 1 hour and counting. We're now 1 hour away from launch of SpaceX's Falcon 9 rocket from Pad 40. The Intelsat 40E spacecraft on top weighs more than 6 metric tons. It's built by Maxar. The Falcon 9 rocket on this mission will be heading to what's known as a subsynchronous transfer orbit. That's a highly elliptical orbit with an apogee of around 15 to 20,000 miles above the Earth, a perigee just a few hundred miles above the planet. And then about 32 minutes after launch is when we expect to see the Intelsat 40E spacecraft deployed from the Falcon 9 rocket. That's when SpaceX can declare mission success for their part of the mission. And then the Maxar and Intelsat control teams will take over the spacecraft for the orbit-raising maneuvers and commissioning before it enters service later this year. We're about 24 minutes away from the start of propellant loading on the Falcon 9 rocket. That's due to begin at T-minus 35 minutes. We expect to have some audio from SpaceX launch and landing control in the final 35 minutes of the countdown, and we'll pipe those updates into our live stream here. Again, if you're just joining us and you haven't done so yet, please hit the thumbs up or the like button here on our YouTube stream. That really helps us helps us to attract a larger audience as we prepare to cover this midnight hour launch from Florida Space Coast. Now 55 minutes, 32 seconds and counting until the opening of tonight's launch window at 12:30 a.m. Eastern Time, 4:30 a.m. UTC. Let's talk a little bit about the Intelsat 40E spacecraft that's launching tonight on the Falcon 9 rocket. It's owned by Intelsat, which has a fleet of more than 50 large communications satellites in a ring in geostationary orbit around the Earth. This spacecraft will be heading to a position in geostationary orbit at 91 degrees west longitude, providing views of North America for the Ku-band and Ka-band payloads on board. The spacecraft was built by Maxar in Palo Alto, California, based on that company's 1300 class satellite platform. According to Intelsat, the launch mass of the spacecraft is exactly 13,582 pounds. That's 6,161 kilograms. And the Falcon 9 rocket will be deploying the spacecraft in what's known as a subsynchronous transfer orbit with an apogee or high point around 15 to 20,000 miles above the Earth. That's a little bit below the orbit altitude that the spacecraft will be operating in at 22,000 miles. The spacecraft will be using its onboard propulsion over the course of a few weeks to raise its orbit and circularize its orbit into that circular geostationary plane. The Falcon 9 rocket is deploying the spacecraft in a lower orbit than usual because of the spacecraft's relatively heavy weight, about 6.1 metric tons, and that allows the Falcon 9 rocket, the booster stage, to reserve enough propellant on board in order to make its recovery landing maneuver to head back to the drone ship in the Atlantic Ocean. On board the Intelsat 40E spacecraft is NASA's Tempo air quality instrument. We'll hear a little bit more about that later in our coverage. Here's a look at the artist concept of the Intelsat 40E spacecraft. In the previous image, you saw the spacecraft buttoned up, folded up in launch configuration with all of its antennas, reflectors, and solar panels retracted against the spacecraft body to fit inside the payload fairing of the Falcon 9 rocket. This is what the spacecraft looks like in orbit when it's positioned 22,000 miles above the Earth, with all of its Ku-band and Ka-band reflectors extended, as well as its two solar panels extended to generate power for the spacecraft's 15-year mission. My colleague Stephen Young had an opportunity earlier this week to talk to Jean-Luc Froliger, the Senior Vice President of Intelsat, a little bit more about the Intelsat 40E mission. Let's air that interview now.
So Jean-Luc, thank you for joining us tonight. Can I ask you, what is the mission of the Intelsat 40E and what services is it going to provide?
Sure. So Intelsat 40E is a high throughput satellites. So it brings in a lot of capacity over North America. Its primary mission is for mobility services. So mobility services means mainly in-flight connectivity for commercial airlines, but it also means in-flight connectivity for regional business jets, as well as mobility for government customers and maritime customers on cruises, for example.
And can you tell us a little bit about the design of Intelsat 40E? Who built the satellite? And walk us through the process of, once it gets into its initial orbit, how the orbit will be raised and the commissioning of the satellite.
Sure. So the satellite was built by Maxar in Northern California. We've ordered pretty much 60 satellites from Maxar over the years. We go all the way back to the 1970s with the Intelsat 5 series. So they're really a trusted partner of us. This satellite is pretty heavy. It's over 6 tons at launch. So because of its weight, the satellite will actually be injected into a subsynchronous transfer orbit, meaning that the apogee, the high point of the orbit, will be below the geostationary altitude. And the Intelsat team was in charge of the mission orbit raising part of the mission. Will first perform a few maneuvers at the perigee, about 200 kilometers altitude, to raise the apogee all the way to geo, to 36,000 kilometers, and then a series of maneuvers at the apogee to raise the perigee to circularize the orbit at geo. This is going to take about three weeks, maybe 3 perigee maneuvers and 4 or 5 apogee maneuvers over a 3 weeks period.
So when will the satellite actually be ready to enter service?
So 3 weeks of orbit raising and another 3 weeks of in-orbit test to check out the payload. It's a very large payload with lots of connectivity and spot beams. So 3 + 3, 6 weeks. The satellite will be ready for service second half of May.
And on this mission, you're hosting a payload for NASA, the TEMPO instrument, which measures air quality. What was Intelsat's role in getting that instrument aboard the spacecraft?
So this is what we call a hosted payload. So it's a win-win situation. NASA gets a satellite to host their payload and a launch vehicle to launch it into space. We get the opportunity to host a payload for NASA, contribute to the science, and on the side get some revenue for hosting the payload. So we had to make sure the payload was compatible with the satellite commercial mission. And then we're responsible for operating the payload. That means gathering the payload data from the TEMPO instrument, formatting the data and sending the data to our customer, in this case, the Smithsonian Astrophysics Observatory in Cambridge, and also be able to command the instrument, right? The Smithsonian will send us a series of commands that they want to monitor a specific city or area in Northern America.
Intelsat launched 6 C-band satellites late last year, 4 on a Falcon 9 and 2 on an Ariane 5. How are those satellites doing?
Oh, they're doing great. 3 of them are already in service today, and the other 3 completed in orbit test, but because they were tested at a different orbital location, they had to drift to their final location. So they're just in the process of completing the drift, and those satellites will be in service in the next couple of weeks. But the checkout, everything, orbit raising and checkout went just as expected.
And is this hectic pace of launches going to continue this year? Can you give us a preview of the next upcoming launches and when those are scheduled to go?
So we have one more satellite launch scheduled this year. That's also going to be on the Falcon 9, and that's going to be our Galaxy 37 satellite. It's the last of our C-band satellite, but it's a larger satellite than the 6 C-band satellite that we launched because it also has a pretty heavy Ku-band payload as well on it. And the launch is scheduled for this summer.
Okay, well, thank you very much for joining us, Jean-Luc, and good luck with the launch.
Thank you. Nice talking to you.
That was Jean-Luc Froliger, the Senior Vice President of Space Systems at Intelsat. We had an opportunity to talk to him a few minutes earlier this week. He told us a little bit about the Intelsat 40E spacecraft. As you heard, it's providing primarily mobile internet services to customers such as in-flight Wi-Fi airplane passengers as well as cruise ship passengers, primarily in the North American market and adjacent maritime regions. This is close to wrapping up a very busy period of launches for Intelsat. Intelsat launched 6 satellites in the second half of last year, primarily for C-band television broadcast coverage. This mission tonight is not for C-band, it's for Ku-band and Ka-band for mobility communications. And then later this summer, in the July timeframe, another Intelsat satellite, another C-band television satellite, is set to launch from here at the Cape on a future Falcon 9 rocket. So a busy time for Intelsat as they refresh their satellite fleet. Again, Intelsat, based in Northern Virginia, one of the oldest commercial communications satellite operators dating back to the dawn of the space age, really from the 1960s. And Intelsat has more than 50 spacecraft in geostationary orbit, providing coverage, communications, video, data relay services all around the planet. And this mission will be heading up to geostationary orbit at 91 degrees west longitude to provide service over North America. We're now about 46 minutes away from liftoff. We're about 11 minutes away from the start of propellant loading if SpaceX is going to target the opening of tonight's launch window. We haven't heard anything from SpaceX indicating otherwise, so right now we're about 46 minutes away from seeing this Falcon 9 rocket lift off from Pad 40. Now 43 minutes, 22 seconds, and counting until the target launch time of 12:30 a.m. Eastern, 4:30 a.m. UTC here at Cape Canaveral, Florida. You're looking live at Pad 40, where the Falcon 9 rocket is just a few minutes away from the start of propellant loading in preparation for launch tonight. Earlier in our coverage, we talked about the Intelsat 40E spacecraft, and we mentioned that it hosts a payload for NASA called TEMPO. TEMPO stands for the Tropospheric Emissions Monitoring of Pollution instrument. It's a visible and ultraviolet spectrometer that'll be measuring atmospheric chemistry across a swath of North America from Mexico City all the way up to Canada. This instrument is about the size of a washing machine. It was built by Ball Aerospace and is managed by scientists and the science team at the Smithsonian Astrophysical Observatory. And as we talk about TEMPO, we just heard from SpaceX Launch Control that they are go for propellant loading and launch. So the team is targeting the opening of the window at 12:30 a.m. Eastern Daylight Time, 4:30 a.m. UTC. Propellant loading will begin in about 7 minutes. So the TEMPO instrument is actually fixed to the top of the Intelsat 40E spacecraft. It's on an Earth-facing panel when it's in the configuration that it'll be operating in orbit. This instrument has sensitivity to measure chemicals such as nitrogen dioxide, sulfur dioxide, ozone, formaldehyde, and other atmospheric pollutants. And the instrument has the capability to make hourly measurements across the entire continent, and in localized areas can actually make measurements of air pollution at intervals of just 5 to 10 minutes. Space-based instruments today only have the ability to do that about once per day. So the scientists will get an idea of time variation in how the air quality varies throughout the day in North America with this TEMPO instrument. The instrument was developed at a total cost of $210 million, and NASA selected it as part of the agency's Earth Venture Earth Science program back in 2012 for development. And we had a chance to talk earlier today with Karen St. Germain. She's the director of NASA's Earth Science Division. She talked to us about the TEMPO instrument as well as some other upcoming Earth science missions that are scheduled for launch over the next 12 months. I'm at Kennedy Space Center with the director of Earth Science at NASA, Karen St. Germain. Karen, can you tell us a little bit about the TEMPO instrument launching tonight?
Yeah, we're really excited about the TEMPO launch. It's been years in the making. TEMPO will give us the first ever capability to see air pollution over North America every hour during the daylight hours at the neighborhood scale. This is an unprecedented capability, and we're really going to learn a lot from TEMPO about air pollution and the processes by which it evolves over time.
And will this data be able to be used, incorporated into operational forecasting of air quality?
Yeah, absolutely. Of course, the TEMPO data will be free and openly available to anyone. But what's really important here is how closely we're working with operational agencies like the National Weather Service, like the Environmental Protection Agency, FEMA, as early adopters to make full use of this data as soon as possible.
And this is one of several Earth science missions that NASA is planning to launch over the coming months or this year. Can you kind of preview what's left in store for 2023?
Yeah, the next one will be the Tropics launch, and this is a really exciting one as well. It'll be a constellation of 4 CubeSats that will fly in a constellation. To give rapid refresh looks at hurricanes as they develop, or typhoons. So it'll give us that rapid time development information that we've never had before. So that'll be our next launch coming up. We're trying to get it launched before the start of hurricane season. And then a little further down the road, we'll be launching, within about a year or a little bit more, we'll be launching 2 more major missions. One is called PACE. It's going to give us an unprecedented view of ocean biology. We'll be able to see not just that there's plankton growing, but we think we'll be able to tell what kind. it is. So that'll be an exciting capability, especially for our coastal communities. And then also a mission called NISAR, which is a mission that we're building with the Indian Space Agency. And that one is really going to tell us about motion, land motion, damage after severe events, and that sort of thing. So a lot of good stuff coming up.
Great. Thank you for your time. That was Karen St. Germain, the director of NASA's Earth Science Division at NASA headquarters. We caught up with her this morning here at Kennedy Space Center. She talked to us a little bit about the TEMPO instrument, how it's going to be providing air quality measurements over North America, as well as previewed some upcoming Earth science missions on NASA's portfolio. Next up after TEMPO is the TROPICS mission, which will be a quartet of CubeSats monitoring tropical cyclone development. Those CubeSats will be launched on a pair of Rocket Lab Electron launch vehicles later this year. The next one, the first set of TROPICS CubeSats, is actually expected to launch in May from New Zealand on a Rocket Lab booster. Now 37 minutes, 25 seconds until liftoff of the Falcon 9 rocket tonight with Intelsat 40E and NASA's TEMPO atmospheric chemistry instrument. We're about 2 minutes away from the beginning of propellant loading on the Falcon 9 rocket. That is set to begin at T-minus 35 minutes. And a few minutes ago, we heard the call from SpaceX Launch and Landing Control here at the Cape that all stations reported go for propellant loading and launch. So we're expecting an on-time liftoff tonight of the Falcon 9. And we just heard a call that tanks are venting for propellant load. So a good sign there that propellant loading is going to begin in less than 2 minutes on the Falcon 9. The launch control team, the engineers overseeing the countdown, is stationed down at SpaceX's Launch and Landing Control Center just near the south gate of Cape Canaveral Space Force Station, a few miles to the
This is LD briefing the abort instructions. For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operators shall call hold, hold, hold on the countdown net. Launch control will abort the auto sequence immediately and proceed into launch abort. At T-minus 10 seconds and beyond, launch control will be hands-off, relying on automated abort criteria for the remainder of the count.
We just heard SpaceX launch director brief the launch team on their procedures that they will need to follow in the event of any abort in the final 35 minutes of the countdown. And the next call we expect to hear from SpaceX Launch Control is the start of that automated sequence and the start of propellant loading in just a few seconds.
Launch auto sequence has started.
And the launch auto sequence has started, so propellant loading is beginning at pad 40. We're now 35 minutes away from SpaceX's 23rd launch of the year, and the 226th launch overall with SpaceX's Falcon rocket family, 216th flight of the Falcon 9. Now 32 minutes, 35 seconds and counting. We're about 2.5 minutes into the process of loading kerosene and liquid oxygen into the Falcon 9 rocket. The propellant loading actually begins with pumping the rocket-grade kerosene and cryogenic liquid oxygen into the first stage of the Falcon 9 rocket. Both tanks on the first stage currently are being loaded, and at the same time as that, up on the second stage of the Falcon 9 rocket, kerosene fuel is being loaded. The kerosene used on the Falcon 9 rocket is known as RP1, or Rocket Propellant 1. It's a highly refined grade of kerosene that has additional impurities taken out compared to your normal jet fuel and other hydrocarbon fuels. At T-minus 16 minutes, liquid oxygen loading will begin on the second stage. So right now, 3 of the 4 propellant tanks on board the Falcon 9 are being loaded for flight at 12:30 a.m. Eastern. Now 31 minutes, 20 seconds until liftoff of the Falcon 9. Let's take a look at the countdown timeline. We've already passed a couple of these milestones at T-minus 35 minutes. About 4 minutes ago, we heard the call from SpaceX confirming that liquid oxygen and kerosene loading had begun. Coming up at T-minus 20 minutes, we expect to hear a call from SpaceX that the RP1, or kerosene load, on the second stage is complete. And then we'll see what's known as the big vent at T-minus 20 minutes. That's the vent of gaseous oxygen from the strongback as SpaceX chills down the liquid oxygen loading line for the second stage. That's in preparation of loading of liquid oxygen on stage 2 at T-minus 16 minutes. And then in the final 10 minutes of the countdown, there will be a series of automated checks of various systems on the Falcon 9 rocket, including the navigation and guidance system, as well as the flight termination system, the autonomous flight safety system that would be used to destroy the rocket in the event of a malfunction in flight. At T-minus 7 minutes, we should hear a call for engine chill down. At 4.5 minutes, the strongback will begin retracting from the right side of the launch vehicle. It'll recline to an angle of about 1.5 degrees from the Falcon 9. Positioning the umbilical connections at the proper location for engine start and liftoff. And then at T-minus 2 minutes, the rocket should be fully loaded with 1 million pounds of liquid propellant. And then at T-minus 1 minute, will be a critical handoff from the ground computer to the onboard flight computer on the Falcon 9, which will oversee the final 60 seconds of the countdown. Propellant tanks will be pressurized for flight. We'll hear a call from SpaceX's launch director that they are go for launch, and then the engine ignition sequence should begin at T-minus 3 seconds. And then if everything looks good, hold down clamps will release at the base of the rocket. 4 of those release clamps will open to allow the Falcon 9 to begin its climb to space. On board, as we've mentioned several times, is Intelsat 40E. Here's a look at the spacecraft inside of Maxar's antenna test range out in Palo Alto, California, where the spacecraft was assembled before it was shipped here to Florida for launch preparations. You see here the KU band and KA band antennas opened up as they will be deployed in space for commercial service. And then on the right side of the spacecraft, on the top side of the spacecraft in its launch configuration, there you see the washing machine-sized Tempo air quality instrument for NASA. We're now getting some camera feeds from SpaceX, thanks to NASA and SpaceX for providing these feeds to us. You're seeing the frost level on the first stage begin to rise. This is from the liquid oxygen loading on board the Falcon 9 rocket. This liquid oxygen is very cold. It's at cryogenic temperatures, so it causes ice and frost to build up on the outer skin of the Falcon 9 rocket, and you're also seeing some of the condensed air created as a byproduct of that cryogenic tanking operation. Throughout the next 20 minutes or so on the first stage, if you look closely, you'll be able to see the frost and ice level actually climb up that first stage as the liquid oxygen is filled in that tank. At the very bottom of the first stage, the area that doesn't have any frost or ice ring, that's where the kerosene fuel tank is located for the first stage of the Falcon 9. We're now about 27 minutes, 45 seconds from liftoff with Intelsat 40E and Tempo.
40 E and Tempo, 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 40 E and Tem
26 minutes, 30 seconds until liftoff. Here's a look at an illustration from NASA showing some of the what the TEMPO instrument will be seeing. This is a visualization predicting some of the concentrations of air pollution that TEMPO is expected to be able to measure and detect from its position in geostationary orbit. TEMPO will be joining a fleet of other pollution monitoring instruments, including GEMS, which is on a South Korean weather satellite monitoring pollution in the atmosphere over the Asia Pacific, including China and India. And then next year, Europe is scheduled to launch Sentinel-4 on a European weather satellite to provide similar coverage over Europe. And then TEMPO is the U.S. contribution to this global constellation of air pollution monitoring instruments. We had a chance to talk to the TEMPO project manager from the NASA Langley Research Center this morning, Kevin Doherty, and he provided an update on the TEMPO instrument and talked about some of the challenges and delays in developing this instrument, which was originally scheduled for launch back in 2017, and also talked to us a little bit about how the instrument makes these measurements. I'm with Kevin Doherty, the project manager for NASA's TEMPO mission here at Kennedy Space Center. He's from Langley Research Center. First of all, Kevin, can you tell us what TEMPO stands for and what it will be measuring from orbit?
Sure. So TEMPO stands for the Tropospheric Emissions Monitoring Pollution. And from our geostationary orbit, where we are above the same point on the Earth at all times, we'll be looking at greater North America and scanning on an hourly basis to look for those gases that are commonly referred to as pollutants across North America.
And how does this instrument work? How will it be able to make these measurements?
So we start with the light that comes from the sun. The light comes down through the air, reflects off of these individual gases that are in the air and goes back out into space. That's where the instrument picks them up. It flows into the instrument, gets bounced through a series of optical elements where ultimately one of those in particular splits out the spectrum, the different wavelengths. So we get the reds, the greens, the blues, all the way through the ultraviolet and the visible spectrum. That gets put onto what we call a detector, which is, you can think of it similar to the detector in a camera that ultimately takes a picture. That data is translated into electronic data, where it gets sent down to the Earth and is ultimately read and then determined exactly what gases were in there based on what wavelengths had the highest emissions.
And this mission is hosted on a satellite in geostationary orbit that's 22,000 miles, give or take, over the equator. Can you talk about some of the programmatic benefits of doing it that way instead of having a dedicated satellite, and also what were some of the challenges?
Sure. So the biggest benefits are saving of money. Building our own spacecraft, it would be dedicated to this mission, or it might have some other instruments on it. But you have to do everything from the testing and the launching and the on-orbit checkout and operations all yourself. So the main benefit we get is that Intelsat was buying the spacecraft already from Maxar, and they have got their own purposes for it. So it was already going to be going up. So we used some of the space on the spacecraft to host the TEMPO instrument and get it up onto orbit. So that saves us quite a bit of money and actually some time, because the commercial spacecraft development world is very, very quick, very efficient, and they can turn around spacecraft off and on like the 2-year time frame. So that was the ultimate benefit of it. But challenge-wise, we initially went into storage because we were trying to find the perfect ride for TEMPO, or a ride for TEMPO, because we needed to line up with the timing of the commercial partners. One of the biggest concerns that they had early on in the program when we were doing requests for information was that if the instrument development got delayed, how would that impact their schedule, because their schedules are so aggressive. So we actually developed TEMPO all the way and put it into storage for about a year and a half before we finished getting ready on the host side in order to move TEMPO out to Palo Alto to be integrated with the spacecraft.
And after the launch, once Intelsat is in geo, they'll take a few weeks to a couple of months, I believe, but once it's in position over the equator, can you talk about the activation of the instrument and how soon will you start getting data?
Sure. So with the launch coming up here overnight tonight, we're going to be We'll be following along as Intelsat gets the spacecraft into orbit and begins to do their checkouts. Come the end of May, they'll be ready for the TEMPO instrument to power up for the first time. So that'll be the very beginning of what we call our commissioning phase. The next major milestone after we finish checking out the different systems that the public will see is in July. In the July timeframe, we will open up what we call our calibration mechanism for the first time. So basically opening up the window that is currently covering the TEMPO optics and let light into the instrument for the first time on orbit. Those will create what we call our first light images, and those will get distributed to the public to show that TEMPO is up, TEMPO is running. From there, we begin doing calibration and validation activities where we look at the data that TEMPO is receiving, combine it with ground information from sites such as Pandora or Tolnet that are on the ground. EPA has a bunch of them, and we will compare the data between the two and help hone in on the settings on the instrument to get the data when we begin regular operations. And then finally, our regular operations will begin at the beginning of October, and we'll enter a 20-month baseline mission where we're collecting and distributing the science data.
Okay, thank you, Kevin, for your time.
Stage 2, RP1 load complete.
That was Kevin Doherty, the TEMPO project manager from NASA's Langley Research Center, talking to us earlier today about the instrument on board the Intelsat 40E spacecraft that will be measuring atmospheric chemistry while Intelsat 40E itself performs its commercial communications mission. We're now less than 20 minutes from liftoff, and this view from UCS-3, a camera site at Cape Canaveral Space Force Station. You can see the big vent is now underway. This is a vent from the strongback next to the Falcon 9 rocket, associated with the start of the chill-down procedure of the line, of the transfer line, where liquid oxygen flows from a ground storage tank up to the interface umbilical that connects to the second stage. This line is thermally conditioned for the next couple of minutes before propellant loading actually begins. Liquid oxygen loading actually begins on the second stage at T-minus 16 minutes. Down below on the first stage, you can see the liquid oxygen level is now over half full on the first stage booster. Kerosene loading also still continuing on the first stage. Again, we want to thank NASA for providing us with this camera view of the Falcon 9 rocket, a little different view than we normally have from the UCS-3 camera site at Cape Canaveral Space Force Station. If you're just joining us, my name is Stephen Clark. I'm the editor of Spaceflight Now. We're now less than 19 minutes away from launch of the Falcon 9 rocket. If you haven't done so yet, please hit the thumbs up or the like button on our YouTube stream. That helps us attract a larger audience as we're now less than 20 minutes from liftoff. Also, if you want to support our coverage, you can do that in a couple of ways. You can join our YouTube channel. We have exclusive bonus video features on our YouTube channel for our supporters, and depending on which level you select for your membership, you can gain access to exclusive bonus features, including those video features that we produced for our supporters. You can also contribute in the Super Chat here on our YouTube stream as well. Any support you provide helps us purchase new equipment and bring you more coverage of launch activity here at the Cape and around the world. Now less than 18 minutes to go. The next major milestone in the countdown will be the start of liquid oxygen loading on the second stage in less than 2 minutes. In the next few moments, we expect to see that vent terminate at pad 40, and then we should hear a call from launch control that liquid oxygen loading has started on stage 2. In parallel with the propellant loading on the Falcon 9, helium, high-pressure helium, is being loaded into composite overwrapped pressure vessels or high-pressure tanks on both stages of the Falcon 9. This helium is injected into the propellant tanks in flight. to maintain pressure in those tanks as propellants, as fuel and oxidizer are consumed after launch.
Start of stage 2 LOX load.
And SpaceX has just confirmed the start of stage 2 LOX load. So liquid oxygen now flowing onto stage 2 right as we saw that vent terminate as expected. 16 minutes, 8 seconds now until liftoff.
Intelsat 40E is on internal power and go for launch.
15 minutes, 20 seconds. We just heard that the Intelsat 40E spacecraft, the 6.1 metric ton payload for tonight's mission, is now operating on internal power and configured for launch. It'll be operating off its internal batteries for the first few hours of the mission until it can deploy from the Falcon 9 and extend its solar panels to begin recharging those batteries. Now 15 minutes until liftoff. .13 minutes, 40 seconds left in tonight's countdown. Haven't heard any reports of any technical problems in the countdown so far. Weather is also favorable for launch tonight. Liftoff still scheduled for 12:30 a.m. Eastern Time, 4:30 UTC on the dot. After liftoff, the Falcon 9 will be heading due east out over the Atlantic Ocean. As you can see in this map, the red line shows the approximate ground track for the rocket as it targets what's known as a subsynchronous transfer orbit, an elliptical orbit ranging between a couple hundred miles altitude up to about 15 to 20,000 miles at apogee, or its highest point. The spacecraft is eventually heading for a position over the equator, and to reach this equatorial orbit, the Falcon 9 will be needing to head due east from the Cape. We've labeled here the location of Space Launch Complex 40, the launch site, as well as the approximate location of the drone ship, a shortfall of Gravitas. This is a football field-sized vessel northeast of the Bahamas, about 420 miles or so downrange, where the first stage booster will be making a landing attempt just shy of the 9-minute point in tonight's mission. Here's a look at the key events for tonight's flight. It's a pretty standard geostationary transfer orbit mission profile. The first stage will be burning its 9 engines for approximately 2.5 minutes, and then the booster will shut down in those engines. It'll detach from the second stage and then begin its maneuvers on a ballistic arc, eventually re-entering the atmosphere and targeting the landing on the drone ship. The second stage will ignite its single Merlin vacuum engine for a 6-minute or 5.5-minute firing to enter a very low altitude parking orbit. And then while that's happening, the first stage will be performing its entry burn with 3 of its engines to slow down as it dips back into the thicker layers of the atmosphere. And then a final landing burn with just the center engine on the booster is set to begin around 25 seconds or so before landing. The booster will deploy its landing legs, and then if all goes according to plan, it'll settle onto the deck of the drone ship at 8 minutes 47 seconds. The upper stage, meanwhile, will coast over the Atlantic Ocean for more than 15 minutes, and then near the west coast of Africa, right as it's nearing the equator for this equatorial crossing, the engine will relight for about a minute or so with that Merlin vacuum engine producing about 200,000 pounds of thrust. That maneuver will actually boost the apogee or high point of the orbit to more than 15,000 miles altitude is the target. And then it will actually maneuver the orbit as well closer to the equator. It'll take out some inclination from the orbit. And then the payload, Intelsat 40E, is scheduled to separate from the rocket at 32 minutes, 22 seconds. And then at that point, SpaceX can declare mission success from their perspective. And then the Intelsat ground team will take command of the spacecraft later tonight, or early Friday morning, I should say, to begin the initial phases of checkouts and commissioning. Now 10 minutes and 15 seconds until launch of SpaceX's Falcon 9 rocket. As you can see, the liquid oxygen level is nearing the top of the first stage on the first stage liquid oxygen tank. That ice level is nearing the inner stage, so just a few more minutes and the Falcon 9 will be fully fueled for launch. Now 7 minutes, 50 seconds until launch of the Falcon 9 rocket from Pad 40 at Cape Canaveral Space Force Station. Let's take a quick look at the various components of the Falcon 9. The first stage, booster number 1076 is its tail number in SpaceX's inventory, is powered by 9 Merlin 1D engines burning kerosene fuel and liquid oxygen. These engines will generate 1.7 million pounds of thrust at full throttle and will target a landing on the drone ship about 400 miles east of the Cape tonight. Above the first stage is the carbon composite interstage adapter, and on the interstage, inside the interstage is the engine nozzle for the second stage of the Falcon 9 rocket. The interstage also comes back to Earth with the first stage, and on the outer circumference of the interstage are the 4 titanium grid fins of the Falcon 9.
Engine chill.
And then above the interstage is the upper stage of the Falcon 9 rocket with a single Merlin vacuum engine. This engine will generate more than 200,000 pounds of thrust, and this engine comes with a larger nozzle for improved efficiency and performance in space. And then at the very top of the rocket is the payload fairing, about 5.2 meters, roughly 17 feet in diameter, about 43 feet or 17 meters in height. And inside that payload envelope, that shell, is the Intelsat 40E spacecraft awaiting launch in less than 7 minutes. Those two fairing halves will actually parachute back to Earth and be recovered by a SpaceX vessel downrange in the Atlantic Ocean. In the last few moments, we've heard a couple of calls from SpaceX confirming that engine chill down is underway. This is a thermal conditioning step to make sure the 9 Merlin engines at the base of the first stage are protected against the risk of thermal shock as liquid oxygen flows through those engines at liftoff. This involves flowing just a little bit of that liquid oxygen, several hundred degrees below zero, through the engine compartment, through some of the engine plumbing, to protect those sensitive hardware elements from the risk of thermal shock. We also heard a call just a few moments ago indicating that the first stage of the Falcon 9 is also fully loaded with kerosene. So right now about 46,000 gallons of kerosene has been loaded into the Falcon 9 vehicle. Liquid oxygen loading will continue for about another 3 to 3.5 minutes or so. At this point in the countdown, final checks should be underway through the automated sequencer of the guidance, navigation, and control system on the Falcon 9, as well as final checks of the autonomous flight safety system. This is the destruct mechanism that would be used to essentially blow up the Falcon 9 if it veered off course and due to a major problem after launch if it threatened any populated areas. We're now inside of 5 minutes until launch. The next major milestone will be the retraction of the strongback. That's the structure
strongback retract
next to the Falcon 9 rocket that will recline to about 1.5 degrees from the vehicle.
Strongback lower started.
And we've heard a call that the strongback lower is now underway. You can see that in the right side of this multi-frame box. The strongback will be reclining to an angle of about 1.5 degrees. The process begins with the opening of a clamp that reaches around the second stage of the Falcon 9. Once that clamp is open, the strongback is free to retract. The booster on this mission, Booster 1076, has 3 missions under its belt. Flight number 4 on tap tonight. It debuted back on November the 26th of last year on a space station resupply mission for NASA. It launched again on January the 9th with a batch of 40 OneWeb Internet satellites. And then most recently, it launched the Starlink 6-1 mission on February the 27th. That was the first launch with a new batch of upgraded second-generation Starlink satellites called the Starlink V2 Mini. We've talked about that on some of our other launch coverage events. This booster will be targeting a landing, as I mentioned, on the drone ship about 400 miles offshore tonight. Coming up on the T-minus 3-minute mark in the countdown.
Launch complete.
The first stage now fully loaded with liquid oxygen. We should hear a similar call about the completion of liquid oxygen loading on stage 2 in a couple of minutes, or less than a minute now. Two minutes, 20 seconds remaining in tonight's countdown. Everything looking good for SpaceX's 23rd launch of the year at 12:30 a.m. Eastern.
Stage 2, lock flow complete.
1 minute 40 seconds. The Falcon 9 is now fully loaded with 1 million pounds of rocket-grade kerosene and liquid oxygen. 90 seconds to go in the countdown now. At T-minus 60 seconds, control of the countdown will be handed off from the ground sequencer
Ground gas closeout.
computer to the Falcon 9's onboard computer. That handoff will start the final startup sequence for the Falcon 9.
Falcon 9 is in startup.
Falcon 9 is now in startup. 47 seconds to go until liftoff. The rocket is carrying the Intelsat 40E spacecraft into
LD,
orbit
go
tonight.
for launch.
The launch director has given their final go for liftoff.
.30 seconds.
T-minus 20. T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, engine ignition, and liftoff of SpaceX's Falcon 9 rocket, bringing improved broadband and air quality coverage to North America. T-plus 15 seconds. Falcon 9 has cleared the lightning towers at pad 40, now pitching downrange. Let's listen to the 9 Merlin engines. Falcon 9 has passed a couple of milestones. It's now past Mach 1, the speed of sound, and has passed Max Q, the period of maximum aerodynamic pressure. It's also pierced a thin layer of cloud cover over the Cape, and it's arcing out over the Atlantic Ocean, heading due east, targeting its equatorial orbit tonight. Now about 45 seconds away from main engine cutoff. Two minutes 20 seconds, standing by for MECO, main engine cutoff, followed by stage separation and ignition of stage 2. And we have main engine cutoff. And we have visual confirmation of ignition on stage 2. We can still see that engine firing now as it's ramping up to full throttle, 200,000 pounds of thrust, continuing to accelerate the Intelsat 40E spacecraft up to orbital velocity, initially targeting a parking orbit just a couple hundred miles above the Earth. Stage 1, meanwhile, beginning its return to Earth, targeting the drone ship a shortfall of gravitas about 420 miles downrange, 670 kilometers, give or take. SpaceX says everything's looking good so far, 3.5 minutes into the flight. Next event will be payload fairing jettison, and we just heard the call for payload fairing jettison, revealing the Intelsat 40E spacecraft to the space environment for the first time. Here's a look at the map from SpaceX showing the relative trajectories of the upper stage continuing its acceleration into orbit. The first stage continuing to head downrange as well. It'll be reaching the apogee or high point of its trajectory in the next couple of moments, and then begin its descent back toward the atmosphere, targeting the landing on the drone ship northeast of the Bahamas. Still seeing stage 2 in the sky here at Kennedy Space Center. See it passing a star. Get a sense of the velocity as it continues downrange. Now showing an onboard view of the upper stage engine glowing red hot as it continues downrange. This engine burns the same kerosene liquid oxygen mix as the first stage of the Falcon 9. 5 minutes 20 seconds. The rocket is now being tracked by a downrange station in Bermuda. This feed from SpaceX shows the velocity of stage 2, 13,400 kilometers and accelerating, 167 kilometers above the Earth. The upper stage, or the first stage rather, now 107 kilometers and descending. Now less than 30 seconds away from the entry burn on the first stage. That will involve a relight of 3 engines to begin slowing down to reduce stress on the vehicle as it falls deeper into the more thick layers of the atmosphere. We might be able to catch a glimpse of that here at Kennedy Space Center. We'll have to see in just a few moments. And we have the entry burn on the horizon. We see the plume of exhaust like a torch descending toward the eastern horizon from the 3 Merlin engines for this entry burn. This is a retro maneuver to slow down for the landing on the drone ship. The rocket will be below the horizon at the time of landing. This map shows the first stage in the final phase of its descent, about a minute and a half from landing on the drone ship. The second stage nearing orbital velocity. The blue line on this map is the shows what's known as the instantaneous impact point. If the burn on the upper stage were to end now, you can see it would fall in the Atlantic Ocean just shy of orbital velocity, but the burn still has about a minute to go to do that final acceleration up to orbital velocity to enter the parking orbit.
Terminal guidance.
7 minutes 45 seconds into the flight. We're the call for terminal guidance. That's the call that the second stage is nearing its target orbit, target velocity and target altitude.
Stage 1, transonic.
The first stage now decelerating below the speed of sound. Coming up in a few seconds will be the landing burn. And there's SECO, second stage engine cutoff.
Back shutdown.
And now switching to an onboard view of the first stage. Landing burn now
Stage 1
underway.
landing burn.
The center engine firing to slow the rocket for its touchdown on the drone ship.
Stage 2 FTS is saved. Nominal orbit insertion.
Stage 1 landing leg deploy.
And we see the first stage has landed on the drone ship, a short fall of gravitas, just a little bit off the center of the bullseye there, but it looks like a safe landing for the first stage, completing its 4th flight to space. Booster 1076 will be brought back to Port Canaveral in the coming days, and then trucked over to the refurbishment hangar here at Kennedy Space Center for preparations for its next flight. The second stage, meanwhile, has achieved its parking orbit. According to SpaceX, it reached the expected orbital parameters and is now coasting over the Atlantic Ocean in darkness, as you can see here. And we're about 17 minutes away from the next maneuver on tonight's mission. That'll be a roughly minute-long reignition of the second stage engine to begin propelling the Intelsat 40E spacecraft up to its higher altitude orbit that will stretch more than 15,000 miles above planet Earth. And that sets the stage for deployment of Intelsat 40E at 32 minutes into the flight. So just to recap, an on-time start to tonight's mission, right at the opening of the window at 12:30 a.m. Eastern Time, 4:30 a.m. UTC. And we saw the first stage successfully land on the drone ship in the Atlantic Ocean. And we also saw stage 2 enter its parking orbit with Intelsat 40E. The spacecraft is heading off on a 15-year mission to provide broadband connectivity for in-flight Wi-Fi and cruise ship internet service in North America and adjacent maritime regions. Also on Intelsat 40E is Tempo, a NASA-funded $210 million instrument to monitor air quality on an hourly basis in daytime across North America from Mexico City up to Canada and from coast to coast.
Expected loss of signal Bermuda.
Continuing its coast downrange, the Falcon 9 upper stage has now passed outside the coverage zone of the Bermuda tracking station. It'll be picked up again in a few minutes over Africa. The next tracking station will be in Libreville, Gabon. 18 minutes, 30 seconds and since the Falcon 9 departed from Cape Canaveral. The upper stage now over the Canary Islands. It'll soon be passing over the western part of the African continent. Currently outside of tracking coverage. It'll be picked up again in a few minutes by a tracking station in Gabon. Here's a look at Space Launch Complex 40, where the strong back has been raised vertical after retracting away from the Falcon 9 shortly or right at liftoff with the rapid retract of the Falcon 9. That pullback actually protects the umbilicals and the structure on the strong back from damage from the Falcon 9's exhaust plume as it climbs off the pad. We typically see this strong back remain in its reclined position about at an angle of about 45 degrees for many hours after a launch. And having covered many of these launches, I've never seen the strong back lifted vertical so soon after the launch, so we're not sure if this is something to do with a new securing or safing procedure at pad 40. It usually remains in that 45-degree reclined position for many hours, sometimes a half a day, before it's raised vertical and then lowered ultimately for rollback to the hangar to pick up a Falcon 9 for the next mission. So we're seeing this now vertical at pad 40. The next mission from pad 40 is set to be a Falcon 9 rocket targeted for April the 19th, about a 12-day gap in launches from pad 40 currently on SpaceX's schedule, an unusually long break between missions from this launch pad given SpaceX's very busy launch cadence this year. Now about 2 minutes away from the reignition of the second stage. This is a critical maneuver that's required to place the Intelsat 40E spacecraft into its targeted orbit tonight.
Acquisition of signal, Gabon.
And we just heard the call that the downrange station in Libreville, Gabon has reacquired signals from the Falcon 9. And now we're getting some video from the upper stage engine showing the engine nozzle that will be ignited in about a minute and a half for this maneuver. The engine will produce about 200,000 pounds of thrust for a 55-second burn. See some of the frost that's accumulated on some of the hardware on the upper stage. That's normal from the cold propellants that is feeding that engine. The liquid oxygen is chilled down to a temperature of several hundred degrees below zero. Now about 40 seconds from engine start. And the upper stage engine has ignited. We're seeing
back ignition.
A great view here of that engine nozzle heating up from the exhaust from the Merlin vacuum engine. See the acceleration of the upper stage on the lower right. Velocity 29,000 kilometers per hour and increasing. Altitude 199 kilometers. This is adding velocity to the spacecraft and the rocket that will result in the orbit being raised, the apogee of the orbit being raised from a couple hundred miles altitude to some 15,000 plus miles above the Earth. Now over halfway through this burn. We'll stand by for engine shutdown in a few moments. And there is engine shutdown, just shy of 35,000 kilometers per hour max speed on tonight's mission.
Nominal orbit insertion.
And nominal orbit insertion has been confirmed. That's the critical call that we were waiting for, confirming that the Falcon 9's engines and guidance system have done their job tonight to place the Intelsat 40E spacecraft into its targeted orbit. Next thing we'll see in about 4 minutes or so will be the separation of that spacecraft from the upper stage. And then at that point, SpaceX's job will be complete. And then the Intelsat ground team will take over control of the spacecraft. Great view here from the Falcon 9 showing the limb of the Earth, the horizon, as it's now 250 kilometers and climbing. It's about 150 miles above the Earth. Currently flying over Africa. In daylight now also. It's now passed into an orbital sunrise.
Acquisition of signal, heart of Bistock.
Now less than a minute away from separation of the Intelsat 40E spacecraft. Another tracking station in Hartebeestok, South Africa, is now picked up telemetry signals from the rocket, and we expect to have video of the spacecraft separation event also relayed through this ground station. We hope to bring that to you live in about 30-40 seconds or so. And here's a view, a forward-facing camera on the Falcon 9 second stage, where we expect to see the spacecraft with its solar panel there folded up against the body of the spacecraft separate from the rocket in just a few moments. Intelsat 40E separation confirmed.
Payload separation confirmed.
This 6.1 metric ton spacecraft has been released from a clamp holding it to the Falcon 9 rocket. You can see the tip off there. Those rates are normal as the spacecraft and the rocket fly apart more than 500 kilometers, more than 300 miles over Africa. Those solar panels on the spacecraft will be extended.
Expected loss of signal, Gabon.
Later this morning.
HPK still primary.
And the ground station in South Africa is continuing to relay this video signal from the rocket. Great view here of this spacecraft, which is really the size of a small school bus, 6 metric tons. This spacecraft was built by Maxar. It will be providing KU band and KA band broadband connectivity for airline passengers and cruise ships in North America and in adjacent waters. Also on board is the Tempo instrument, a NASA sensor that will be measuring atmospheric chemistry, particularly looking for constituents in the atmosphere that are part of air pollution in cities across North America, as well as in Mexico and Canada. We've lost the live view with SpaceX having concluded their live video coverage. But that was a spectacular separation event that we saw relayed live from the Falcon 9. We're now back on a view of Pad 40, where the Falcon 9 lifted off 34 minutes ago at 12:30 a.m. Eastern Time, 4:30 a.m. UTC. We're going to go through some of the mission stats for tonight's flight before we sign off. This was the 216th launch of a Falcon 9 rocket since 2010, the 226th launch overall of the Falcon rocket family. This includes SpaceX's Falcon 1, Falcon 9, and Falcon Heavy missions. This was the 4th flight for the booster number 1076 from here at Cape Canaveral. The 184th launch of a Falcon 9 from here on Florida's Space Coast. The 120th SpaceX launch from Pad 40, which you're continuing to see live, and the 175th launch overall from Pad 40, including SpaceX Falcon 9 flights, as well as more than 50 launches of the Air Force's Titan rocket, dating back to this pad's entry into service back in 1965. This was the 156th flight, of a reused Falcon booster. It was the 184th successful landing of a Falcon booster, including Falcon 9s and Falcon Heavies, the 4th SpaceX launch for Intelsat, and the 23rd SpaceX launch of the year, the 18th orbital launch attempt from here at Cape Canaveral so far this year. Primarily, those have been SpaceX missions. One of those was the failed orbital launch attempt, the test flight of Relativity Space's Terran 1 rocket last month. Thanks. And as we conclude our coverage, we'll look ahead to launches we'll be covering over the next couple of weeks. The next SpaceX mission is scheduled for Monday night or Tuesday morning, depending on where you are. This will be the Transporter 7 small satellite rideshare mission launching from Vandenberg Space Force Base in California, carrying dozens of CubeSats, microsatellites into a polar orbit from Vandenberg. These satellites are owned by a variety of customers, government agencies, commercial companies around the world. That launch is scheduled for 11:48 p.m. Pacific Time Monday night, 2:48 a.m. Eastern Time Tuesday morning. Later next week on April the 13th, next Thursday, will be the second to last or penultimate launch of Europe's Ariane 5 rocket. This will be a significant mission because it's carrying the European Space Agency's Jupiter Icy Moons Explorer, or JUICE mission, from the launch pad down in French Guiana. This JUICE mission will be flying to Jupiter on a decade-long journey across the solar system, and eventually will enter orbit around Jupiter's moon Ganymede. It'll be the first spacecraft to enter orbit around a moon of Jupiter. And then the following week, no earlier than April the 17th, although a launch date has not been confirmed from SpaceX, will be the scheduled launch, the test flight of SpaceX's Super Heavy and Starship launch vehicle from Boca Chica Beach, Starbase in South Texas. This test flight is a long-awaited launch of the full stack, the nearly 400-foot tall or 120-meter tall Super Heavy booster and Starship. And then the following day, on April the 18th, we'll be back here at Kennedy Space Center. That's the next SpaceX mission from here in Florida. A Falcon Heavy rocket will be launching the Viasat-3 Americas broadband satellite from Launch Complex 39A at Kennedy Space Center. This will be the 6th flight of a Falcon Heavy rocket and the second Falcon Heavy launch of the year, the second of as many as 5 Falcon Heavies planned for launch in 2023. So that's a look ahead at the launch calendar over the next couple of weeks. These launch dates are always in flux, so be sure to go to www.spaceflightnow.com and check our launch schedule for updates on these launch dates, as well as other missions planned for launch over the coming weeks and months. We'll leave you with one final look at Pad 40, 38 minutes since the Falcon 9 lifted off. Again, the next mission from here on Florida Space Coast is scheduled for April the 18th, the Falcon Heavy. The next SpaceX mission overall will be out on the West Coast at Vandenberg Space Force Base, California on Monday night, local time. My name is Stephen Clark. I'm editor of SpaceflightNow.com. Thank you for joining our coverage tonight. I want to thank Stephen Young also for camera support and video production support tonight. Have a great weekend. We'll see you next time.